have a look at this experiment which I performed earlier with one of my students. So you can see on the right hand side, we have a teddy bear. This is very light teddy bear, a 200 grams teddy bear. And on the left hand side over here, you can see this is a dumbbell. A dumbbell is a gym equipment which people use to exercise. It is very heavy. So now have a look. We have a 200-gram teddy bear versus a 3 kilogram dumbbell. Now watch carefully. Both of these objects are at the same height. And if we release them, just check which object hits the ground first. Watch carefully in the slow motion. Okay, so Burandin, what do you think? Which object is hitting the ground first?
Sir, both together.
Right? So now, what do you think is actually happening here? So that is why I told you a heavy object versus a light object. Both will take the same time, which means you can take a very heavy bottle of water and a pen cap also. They will also take the same time. Right? So that's the experiment. So going a little ahead. Okay. Please analyze this very carefully. Right now, I showed you the video in which I have a 200-gram teddy bear versus a 3 kilogram dumbbell, and the height is the same. Okay, now who can tell me? Let's say if we increase the height, let's take a bottle of water and pen cap, and if we increase the height, then is the result going to change or will it be the same? Let's see. So the same experiment I had done with my current students. So just have a look. Okay, have a look. It's the same setup. The 200-gram teddy bear versus a 3 kilogram dumbbell. This time, the height is bigger. So watch carefully. Please pay close attention and look which object hits the ground first. Watch carefully. It will be in slow-mo. So watch carefully. Even if you increase the height, the result is actually the same, right? So what have we learned so far does not really matter. You can have the most heaviest of the object and the lightest of the object. The time taken to fall to the ground is actually the same. Does it make sense, all of you? So wasn't this experiment fun? Yes, Burandin, you have a query?
Yes, sir. If we take a feather and if we take a water bottle, will it land at the same time?
No. Burandin, that's an amazing, amazing question. Hats off to you. So what do you think, Burandin, will happen? Let's say if I take a heavy bottle of water versus a small feather, which is going to hit the ground first?
Bottle.
And yes, but this time, why is the logic not working with the feather? Everyone, try this out. Why feather takes a lot of time to hit the ground? Please try. Sasha, Divya, Jaden, Niti, Anurag.
Sir,
One sec, Burundin. Yes, Sasha, go ahead. Unmute, unmute.
it floats and come like this is a feather.
Yes,
Comes
yes,
like
amazing.
this.
Okay, so everyone, if you take feather, see, feather will float on its own. See, it's like a paper. If you release paper from the height, it is just going
Like
to float.
paper aeroplane.
Yes, just like a paper aeroplane, feather also has a tendency to float. So, Burundin, answering your question, let's say if I remove all the air, let's say if I remove all the air from the room and then you do the same experiment, feather versus a bottle, then you know what, Burundin, what will happen? Everyone, a bottle versus a feather will fall at the same time if you can remove all the air from the room. And if you want, I will just send you the
We
video
remove
of
all
that
the air,
experiment.
तो भी एक इसमें they will fall at
One
the same
sec,
time.
let me
There is no
unmute.
air, and they will fall at the same time because there is always air in the.
Okay, so sorry, all of you. Please keep yourself muted unless you have a doubt. Okay, so the experiment, remember, was what? A teddy bear versus a dumbbell. Now, just have a look. I did another variant of this experiment. So, have a look. This time, see, this is a very, very heavy dumbbell. It's a 10 kilogram. and this is my brother, and this is me. All right. So have a look. It's a 10-kilogram dumbbell, which is so heavy that it is very difficult to lift. And then you have a 200-gram teddy bear. Observe which of the two hits the ground first. So watch. Okay. Look at the slow motion. Which of the two is hitting the ground first? Okay. So see, same concept, same concept, does not matter. You can have the heaviest of the object and the lightest of the object. The time taken to hit the ground is the same. Okay. So did all of you understand the logic and the concept? Just write yes if you have understood. And I want you to perform this experiment later on if you haven't done already. So please, okay, so Asmi said yes. Others, please quickly write down yes or no if you have any queries, and write that also. So this was the first experiment on gravity. And see, it is very simple. Just take any two objects, one heavy, one light, release them from the same height. It will take the same time. And for that feather experiment will work only if you remove all the air out. So that is vacuum. That video I'm going to send you after the workshop. All right. So let us move ahead. So we are done with the first experiment. Now, then have a look. All of you have a look at this picture. I want you to just text or tell me what is the first thing which comes to mind when you see this picture. And please participate. Please do participate and ask lots of questions. And yes, who will try this? Just try. What's the first thing which comes to mind? Text or raise your hands. Okay. Yes, Divya, Myra, Anurag, Niti, Minu. Just try. Yes, Sasha. What's the first thing?
It
Unmute
has,
yourself.
sir, because it has more air. The balloon, the mota balloon.
Okay. The Mota balloon has more air. And what about this?
This is just a normal.
Correct, right? So this is a simple picture. So more air means more weight. So let's do an experiment based on this. So have a look. See, this experiment you have to perform later on after the workshop. See, we have a paper boat. We have created a small paper boat, and then let's see. This is a glass container, right? On which we will keep the boat, paper boat. So understand the apparatus. It is just one glass container, some water, and a paper boat, right? Okay. Now again, you have to answer, and let's see who can answer this. It is going to be interesting. So one sec. Okay, so let's see who can answer this. Burundin, you have already raised a hand, but fine. Let me ask the question first. Look at the experiment. We have taken another glass container and put it on the top of the boat. So have a look. You need to tell me. Okay, so you need to tell me when we push the glass on top of the boat, what is going to happen to the boat? Is it going to go down into the water? Is it going to become wet? Will it be dry or what? That is the question. So yes, Purandin.
Sir, the paper boat will become wet because when it is on the water and we put another glass and push it, so the air is getting pushed, and because of the air, the paper boat is going to sink.
Okay, so you're saying the boat is going to become wet. Let's see. Anurag, yes. What is your opinion on this, Anurag? Tell me.
The boat will sink.
The boat will sink, but will it become wet, Anurag? That's the question.
No, it will not become wet.
Okay, so yes, let's see. Let's check. And Sasha, yes.
Yeah,
Unmute yourself.
yeah. So the boat will sink.
But oh, good, fine. So will it become wet because the boat is going in the water? So will it sink? Will it become wet? That's the question.
उसमें ज़्यादा पानी भर जाता है, then it can sink.
Okay, fine. We'll check that. by performing the experiment. And yes, Myra, what do you think? Please unmute yourself and
I
answer.
think that it will not sink.
Okay, so
I
Myra is
think
saying,
the boat will not sink and that it will not get wet.
okay, let's see. Let's check. All of you, please pay attention. We are starting off with a paper boat. We put it on water and then we push the boat. Second, sorry. So we push the boat with the glass container. So have a look, all of you, watch carefully what is happening. The boat goes inside the water, right? So the boat actually sinks, but look at the boat. Do you think it is wet or dry when it went into the water? Let me play this again. All of you, please watch very carefully. When we push the glass downwards, look, have a look. The boat is going into the water. It's completely inside the water. The magic here is the boat is actually dry. It's not wet. The water did not go into the boat, right? And why the water did not go into the boat, that is we have to understand. So can anyone try? The boat did not get wet at all, even though it is inside the water. Who will try this? Why the boat is not getting wet like you just saw? The reasoning is very, very simple. Okay, who is going to try? Asmi, you have an answer to this? Others, please try this. It's a simple explanation. Okay, no problems. Let me explain. With another experiment. See, in this particular experiment, you needed a paper boat, but that's not necessary. You can just take any piece of paper, just crumble it up and, okay, well, one sec, I'll just show you that experiment. So just take any piece of paper, crumble it up, and then have a look. So watch, we have a paper piece and we put it inside a glass. So watch carefully, extremely carefully. See, then the paper is inside the water. It's completely inside the water. But when you take out the glass from the water, look at the paper. It's not wet. It's actually dry, right? And what is the reasoning behind this? So all of you, please perform this experiment. It's very important. But for now, let's understand the logic. So have a look. What is the explanation? So right now, watch. Everyone, please have a look at your screens carefully. We have a paper piece inside the glass, and above the paper piece, you have a air. And this is the air which is keeping the paper dry. So have a look. When you invert the glass and put it inside the water container,